Welcome everybody. I'm Ken Clairbout, K4ZW. Glad you could join us today for our presentation. I think we've got a good one lined up today. We're very happy to have Jukka Klemola, Ocean Hotel 6 Lima, India with us today from Finland. And I've had a chance to look at a little bit of his presentation. I think there's some great information in here that he's going to share with you today. As we do in all these presentations, we will hold your questions until the end. You're certainly welcome to submit them at any time, but just to keep the presentation smooth and flowing, we're going to hold the questions to the end. So with that, I am going to kick it across the Atlantic Ocean over to Finland, and Jukka, you can go ahead with your presentation. Thank you very much.
Okay, thanks, Ken. Good evening, everybody, or depending on your time zone, hello there. So I'm Jukka, OH6LI, and I'm very proud that I was invited here to present my old slides, cost of the decibel, and I'll try to show you couple of ways how I have been designing my systems, my contestations, OH4A and OH0V. So the menu or the contents of this presentation is like, let's look at the decibel, what it is. Then we will have a look through the whole contestation, whatever there is, like transmitter, power amplifiers, etc., all the way to a recipe for the average ham. And let's see if we have time. I will try to explain what and how I have been doing my compromises. So all our stations are compromises, and so this is just a food of thought for everybody. So decibel is a single strength measure. So how about your experience? So if there's a signal rise from S8 to S9, does the signal strength double? Or if we go from S9 to S9 plus 10, what happens? So mathematically, because this is engineering science, an S unit is 6 decibels. And 6 decibels equals quadrupling the power, and 10 decibels is like 10 times the power. 3 dB is doubling the power, like many of us know. But just for repeating and making this kind of basic assumptions clear. So there is a bunch of thoughts, or there's a line of thoughts, and I have been referencing myself, my own antennas, my own everything that I have been doing is like 100 watts plus a dipole up 15 meters gives a 5.9. Then I have been trying to think that, okay, how do I develop this? How do I make a better compromise for myself? So starting a little bit like thinking, so 500 watts means 5.9 plus 7, or 1000 watts means 5.9 plus 10 decibels. And in case you don't know what is required for 5.9 plus 20, in this case, it's 10 kilowatts. And even that does not really double the experience of the signal strength, at least not to me, strangely. Looking to the other direction, so if we would be transmitting just like 10 watts to the same 15-meter high dipole, we would be getting like 5.7 plus 2 decibel signal. But how about 5.5 report? What would be required? It's just below 400 milliwatts. And the guy is still audible if he was showing a 5.9 report with 100 watts with his dipole up 15 meters. So then let's go into transmitter. Let's see what happens. So I have seen some people that have been forcing off a little bit more from their transmitters than the usual 100 watts. So what happens? So the real signal rises maybe a decibel, so that there would be something like 108 watts or 109, maybe even 110 watts on the channel. But what really happens is that the equipment heats up, and that's because of it's forced to give a little power over the real capacity. And the problem there is that the signal will spread out a little. So this is the big point here. So as there is some misuse for some stages of the equipment, it means that the rest of the contesters are going to pay for this one guy that is overdriving. So with transmitter, if you are not using an amplifier with your only transmitter, if you are squeezing out something a little more than 100 watts, it's going to be disturbing everybody else. And it means that the lifetime of the equipment will be shortened. So the problem there is that the transceiver will break also elsewhere because it's heating up, so that at the transmitter the last decibel costs the transmitter. So don't do this. So that's my message for all of this. Then let's look at the power amplifier. So let's see if it pays off to invest for 1500 watts, which is about 12 decibels over 100 watts. So you are getting only 3 decibels over 800 watt amplifier like some smaller Ameritron amplifier. So here in Europe you can get that kind of new amplifier 800 watt device at around 1100 euros, or it's like 1500 US because it has been imported, etc. And a 1500 watt amplifier would cost something in excess of $3,000 or 3,000 euros. So I'm estimating that today in Europe we can buy a 1500 watt capable amplifier at something like 3,600 euros. So the power amplifier decibel, it will cost about 120 to 300 euros per decibel, and this will not improve receiving. But now here's a big kicker, here's a big point. So the last 3 decibels, they cost 800 euros a decibel. And even with a second-hand or used amplifiers, you will be paying close to 500 euros a dB for the last 3 decibels. So let's try to keep this nearly 500 euros per dB as some kind of reference figure in our minds through the presentation. So then there's this question that should we be overdriving our amplifiers? The answer is no, it really does not, because the losses are going to rise exponentially. The temperatures are going to be giving problems to parts inside the amplifier, and especially the grid is a really fast fuse. I have seen dead 3500 Zulus, and I have been wondering why these guys are not taking care of their amplifiers like the way they should be doing, because the tubes, no matter what kind of tubes they are expensive. And it's not only the tubes, but the temperature will be rising at all parts of the amplifier. Then going to receiver. So like some decades ago, the sensitivity has been one measure, one important measure for the receivers, but it's no longer a problem for us. So the differentiator between the receivers, whether they are good or bad or adequate for us, it's the ability to show or receive a weak signal that is next to a very large or big signal. About 80 decibels dynamic range is typical for today's market. And if you want to improve any of that, you are going to need some crystal filters, and especially in the first IF, which is called the roofing filter. And some of the latest transceivers have the roofing filter built in, largely because of some architecture changes in the receiver. But here at this receiver, this roofing filter decibels, if you are getting an improvement of about 10 or 20 dB for this some kilohertz separation, it means that you are paying only about 20 or 10 euros a dB. So these are pretty efficient euros. And there is some humor for the Finnish audience, if there are any. So 3699 is 80-meter round table we have in Finland, and I hear nearly every week there somebody is saying that he got that DX, he could hear the DX because he has the big amplifier. Well, that's not really the case. Receiver is the receiver. Then let's look at the tower. So all my antennas on my towers are horizontal, and I think all hams have only horizontal antennas on their towers. So if we are raising a horizontally polarized antenna upwards, it will be increasing the gain at lower takeoff angles. But then there's a big problem if you are going over half wave, then you go over a wave or two waves. It means that there are going to be such lobes that will have less gain, or they have notches or dips in the gain. And some takeoff angles are going to suffer dramatically, especially on 10 meters. If you go with your antenna about 10 meters height, then you are going to have some losses of gain at some takeoff angles. The antenna's gain itself does not really change, but the main lobe will be going downwards, and then there will be some dips in the gain. So if we are looking like this, so there's a 20-meter dipole that's up 3/4 of a wavelength. So this happens to show the peak gain about 7.7 dBi at about 20 degrees takeoff, and there's a decent gain at about a 0 dBi gain at about 5 or 7 degrees takeoff. But then look at this red arrow. This is really a big case for everybody to understand that there are going to be this kind of I would call this a problem area. So there's so much less gain, but on 20 meters there are going to be stations that are coming into your antenna at something like 35 degree incoming angle and above, and you are not going to be competitive with those. So you need to design your antenna system so that you can hear also everybody that are coming in with a little bit higher incoming angle or takeoff angle. Then if we double the height to 30 meters, there is going to be much more gain at about 5 or 7 degrees, but then there's a first big problem now at 20 degrees. So the previous case was that we had a good gain at 20 degrees. Now we have negative gain. We are attenuating signals that are coming in at 20 degrees incoming angle, and I consider this a big problem. So if you have a contest station, you have your 20-meter antenna up 30 meters, you are going to have a problem if you don't have another antenna that is lower or higher. And then if we go still more up, we are going to 45 meters with our 20-meter horizontal antenna. The gain at low angles is going to be even higher, but we are going to have these problem areas, many of them. And this happens with all horizontal antennas. Then let's go to 80 meters. So this kind of dipole up 15 meters, it's basically radiating upwards. Then if we rise it a little bit, it will be better for the DX. And then going to 60 meters, it's going to be even better for DX. But now you can see that there is this same problem again with incoming angles of about 45 degrees plus minus something. So trying to summarize the tower effects or antenna height effects. So the gain directly to the horizon, I mean zero angle, it's always very small. But there are, this is not a surprise, but then there are surprises as some examples. So 80-meter horizontal antenna up 60 meters is not going to be serving you well, because you are going to have the problem with these incoming angles between 35 to 60 degrees, and everybody knows that on 80 meters we are going to have this kind of signals coming in. And on 20 meters, if you are having your only antenna up about 45 meters or 150 feet, it's not going to be good, because you are going to be having much less gain at about 12 to 16 degrees. So when you are investing into a tower and your antenna, it's worth knowing that what you are going to lose when you are gaining something. And the close range antenna is not the same as your best DX antenna. So how to get over this kind of problems is that you can have multiple antennas at the various heights, or you can stack. So I estimated here, these are just some figures, so some numbers for discussion. So a 30 meter or 100 feet tower could cost something like a little less than 2,000 euros, but a 60 meter tower would cost around 6,000 euros minimum. If it's assembled, it's going to be even more. And theoretically on 20 meters at 2 degrees elevation, if you model this on an average ground and flat ground, you are going to have about 6 dB more gain, and this would be showing you 675 euros a dB. But let's see now. So if we take this kind of propagation forecast from Finland, Vaasa area to Kilo Hotel 5. So with a system capable of 7 degrees, you are going to have maximum signal of minus 132 decibel watts as per this, and you are going to have a certain amount of propagation. Then by making a higher system, like going to 60 meters with this antenna, you can have a little bit longer propagation, but you are going to have also a better signal like minus 120 decibel watts, which means an improvement of 12 decibels. So if you can access that 1 degree instead of being able to access only 7 degrees, you can lower the path loss by 12 dB. So now this figure looks much better. So it's only about 220, 230 euros a dB per this calculation, and you are going to have more propagation or longer propagation window to the KH5. So you can all think about your own systems using this kind of analysis. Then let's look at the antenna. So if there's a dipole, it shows about 2.2 dBi in free space, and 2-element antenna a little bit more, etc. So let's go and try to think about 10-meter antennas, which are small. They are pretty lightweight, and they are not so costly. So it would be 10-meter 4-element Yagi would cost about 49 euros a decibel. There's of course the rotor and assembly and all that. If you buy or if you invest for a 6-element Yagi, it's roughly the same, maybe even a little bit less. But you are going to have a little bit heavier rotor, and the assembly is going to take more time. It's going to be more difficult overall. Then going to 20 meters, so I'm skipping the 15 analysis. So going to 20 meters, you are going to be doubling your money per decibel. And now you can see that the 6 elements is going to be costing more. But now you can see a bigger figure, like the last 2.5 decibels will be costing 160 euros a dB. But now remember what there was about this power amplifier. This is very small money. So investing in your antenna is always good, because this is going to help you also with receiving. So I have some analysis here on YT software, Sanction 6BV. So you can see maybe this green dotted line, which is a 1 Yagi up 150 feet or 45 meters. This is with a ground pattern of my OH4A QTH towards Victor Kilo. Then here is a 30-meter high antenna, and then this red line is for a 15-meter high antenna. So there is big surprise that this low antenna that is only up 15 meters is going to be better than either of these antennas that are high. So it will show more gain. And I have verified this in practice, so I had a problem understanding this. But it's really a reality that the high antenna will be winning for the absolute DX, but when the other stations are closer, then the lower antenna is better. And then if you stack, here is a high stack, this green dotted line now, it's a high stack, and then here is this 15-meter high single antenna. And this is for real. So if I'm working Europe, this low antenna is about the same or much better than the stack. So the way I have arranged this at OH6LI is that I have a low antenna and I have a high stack. So then going to 40 meters. A horizontal antenna must be up at least this 15 meters to be in any way like usable in international contests. And if raising it up, it will help, and it will help dramatically. But if you go over one wavelength, you are going to see the same thing again, that the gain drops here for the high antenna and the lower antennas are better. The high antenna really loses to these lower antennas on paths of less than 1,000 kilometers. And now the 40-meter antenna cost is going to show. So that if you are investing in a 2-element Yagi on 40, which I have selected, you would be paying about 200 or 250 euros a decibel. And if you are going to increase your antenna or improve your antenna to a 3-element thing, you are going to be paying for the last decibel or decibel and a half, you are going to be paying something like 500 euros per decibel, which is a lot of money. But there's of course this improved radiation pattern for receiving, which is difficult to calculate. But if you want to have a 3-element, you do that. And the motivation for that would be the receiving radiation pattern. Then let's look at 80-meter horizontal antenna at 15, 30, and 45 meters. So here is something strange that I noticed. This white line, which is at 100 feet or 30 meters towards VK from my location. So what I have at OH6LI is I have a 80-meter Yagi up 35 meters. So I'm taking a full advantage of this low angle radiation, and I'm taking some kind of punishment, maybe decibel and a half here on upper angles. But it's only to this one direction, and to other directions it's less problematic for me. And there's a 2-element Yagi in this simulation model. Then about ground plane on 80 meters. So you were seeing now horizontal antenna gains, which were like, if you look at here, a 2-element Yagi shows about 11.2 dBi. And now we are going to look at the ground plane. It's going to show like minus some dBis. Or if you really have some kind of advanced system, you can say that you have about 0 or maybe even 1 dBi gain at maximum of your ground plane. So this is real figure also. I have verified this. But if you don't have a possibility to have a horizontal antenna up somewhere like 30 meters or 100 feet, then this ground plane is going to be much better. So if you have a horizontal antenna up only about 15 meters, or you have a ground plane, your ground plane is going to be much better. But you're going to be losing to guys that have horizontal antennas up about 30 meters or more. So the 80-meter ground plane antenna pattern looks like this. So it's not good for close by contacts, but this is relatively okay for the DX. And this is modeled using NMA software. So this model shows about half a dBi gain. Then if we're looking at multiband antennas, So a normal tri-bander or larger tri-bander, they cost something. And if we are comparing this to something like a dipole or so, then we can have pretty decent figures for this kind of horizontal antennas. And these multiband antennas, when you are building your first station, or you have a city lot QD8s, or you don't want to have multiple towers, etc., and you don't want to stretch your money to the end, these are a very good investment. So they're like around 50 euros a decibel, and they give you a lot of opportunity to get DX. Even if these are up only about 15, 20, 25 meters, these are going to be the best investment that you can make. Much better than any amplifier or getting the last 10 watts out of your exciter. Then if you're trying to stack the tri-banders and trying to compare that with a larger tri-bander, so if you want to have this kind of game of thoughts, then you will be getting about the same gain like a smaller tri-bander, stack of those versus a larger tri-bander. But you are going to be spending a little bit more money, but you can drive your RF to two directions, and there is a number of benefits with this kind of stack as compared to a larger tri-bander. Then if we are looking at multiband verticals, the good multiband vertical would be costing about 500, 600 euros here today. Then a multiband vertical kind of shows bad gain figures on paper if we are comparing that to a dipole. But there are many ifs, there are many preconditions. So if the vertical is on roof, the gain estimate is about valid only if the dipoles are on a tower in free space and are rotating. But if the vertical is high, so if you can place your R7 or R8 vertical, for example, if you can place it very high, then it's going to operate just fine for you. And even if you are making the dipoles at home of some electric wire and so, they are going to be costing, and the feed lines, all the separate feed lines are going to be costing something. So if a multiband vertical is in practice the only thing you can have there, it's worth doing. Then solutions for the antenna. So for the average ham, it's really most cost efficient to buy a multiband vertical or multiband antenna and place it as high as possible, and keep safety and keep reliability in your mind also. And what kind of antenna you can have, the real estate is always setting the limits, for my stations also. And for larger antennas, the decibels are going to be as good for money, but the rotors and other related equipment, they are going to be more expensive, and they are going to complicate the calculations. But if you want the decibel, you need to understand that you will be paying also for something. And if you are placing two multiband antennas, it will give benefits over one multiband antenna. But you need to be able to get those into free space somehow. And then the more decibels you have kind of invested for, the next decibels are always going to be more costly. Then if we are looking at the feed line, so I have been using RG213, but then I started thinking that, okay, is it worth investing into a thicker cable? So if I have a 100-meter runoff cable on 10-meter band, it was easy to understand that it's worth investing into much better cable, even if you have to buy the cable new. I have been able to find surplus cables that are roughly the same cost as new RG213. So I have been very happy with my thicker cables. And even on 80 meters, if the benefit you are getting from a thicker cable would be like more than 500 euros a decibel, it's better efficiency than investing into a third element, or this investment level matches just about the amplifier investment level, if you remember the first calculation. And if you are selecting or if you are choosing to use a multiband antenna, you are going to be using less cable. So investing in a thick, good cable is going to be very efficient. Then about peripherals. So antenna switches, etc. They usually show figures less than 0.2 dB, but I have found out that you need to kind of keep your relays in good shape. You have to clean your box of dust, etc. every now and then. So then you can have your switching losses to a minimum. So first build something or buy something and install it, and then keep it in good condition. And understand and keep in mind that whatever you are investing for 500 euros a dB is not really that much if you have a big amplifier like 1500 watt amplifier, or you have a 40 meter 3-element full-size Yagi. Then speech processor, if you are using it wisely, it can benefit you, but if you are using it wrong, it will ruin your contest operation. And then also your own behavior on the band, the way you are talking or you are transmitting or receiving. These are such things that don't have a money sticker on them, but we need to understand that they are parts of our contest operations. So here are the compromises I have been doing. So we have about 100 kilometers an hour winds here in the mainland, and on OH0 we have something like 150 kilometers every year, maybe every 10 years, 180 kilometer winds. So what I have been doing on upper bands, I have stacks on upper bands, and they are as high as possible. And then I have a low tri-band quad at OH4A. I don't have that yet at OH0V, but I'm planning. I have been pondering what and how to do there. Then I have full-size Yagis on 40 at OH4A, but I have shortened Yagis at OH0V. And on 80, I have a Yagi, which is this Yagi here, if you can see it in the picture. That's the 80 meter 2-element shortened Yagi, and I have wire antennas at OH0V for 80. So it's because of reliability and construction difficulties. I have thick surplus cables, like I said. I have really heavy-duty switches, relays, and I'm maintaining those. All my amplifiers are second-hand. I haven't been buying any of my amplifiers yet new, and I'm using old Yaesu radios, and I have roofing filters for all them all. So the sources for this, so thanks to Olli OH2BBR, I was maybe 15 when he published his Antenna Techniques book, and I have been reading it regularly ever since. N6BV, thank you, and bunch of people, W6EL, OH6BG, K6STI, W7EL, and also ON4UN, who has this terrific book, Top Band DXing. And I have been getting a lot of information from Top Band mailing list and also AMP's mailing list. So thank you, Ken. This concludes my presentation, and I think we can move to questions.
Okay, Jukka, very good. Thank you very much. Very interesting material there. So if you have any questions, now's the time to go ahead and send those in. There's a little question box. Type that in, hit send. I'll go ahead and pick that up and send it back to Jukka. You know, as you said, the last few decibels are the usually the most expensive, but sometimes that's what separates you from from the other stations in the contest or the pileup. So, and it's interesting too for most of us. And before this started, Jukka and I were talking about the weather up there in Finland and over here. And for most people in the northern hemisphere, this is kind of an odd time of the year to be talking about antenna planning and so on. But actually, it is a good time because during the winter you can stay inside and do some planning, get some ideas. Hopefully these webinars will spur some ideas or get you thinking. And then when the springtime does roll around, you're all set and ready to go. So I am not seeing any questions coming in, Jukka. Looks like you have covered everything perfectly. But go ahead. Okay.
Yeah. Well, in case there are no questions, I'm a little bit surprised, but I was wondering how to calculate into these money calculations, like assembly or rotor costs or anything like that. I didn't go to that kind of complicated things because we agreed that we have 1 hour for the whole presentation.
Sure. Okay, I've got some stuff coming in here now. Okay, Hunter's asking, would you suggest using hardline for 400-foot run of coax? So that's...
Yes.
Okay.
Yes, definitely.
Especially at the higher frequencies too, right?
Yes. So on 10 meters, if you can find hardline at a cost of let's say we can buy RG213 in Europe at cost of about €2 or $250 a meter. So it's about $1 a foot. So if you can find hardline at double of that cost, it's a great deal. If you can find hardline at 4 times that cost, then it's a bit there and there, but it's a cost matter. And one big thing that I have found with the hardline is that it's much more reliable cable than RG213, which is pretty soft, and you can ruin or you can punch a hole in your 213 pretty easily, but hardlines, they are much more rugged. So if you're climbing your tower, etc., there are also other kind of aspects in what comes to investing into hardline. So for me, it has been a clear yes.
Oops, okay. It helps if I unmute myself before I start talking.
Okay.
Okay, someone asked about the slides, if they'll be available. This presentation, by the way, is being recorded and will be posted to the WWROF webpage under the webinar archive. And if you're interested in the slides, drop Jukka an email and see what we can do.
Yes, I can share the PDF to anybody.
Okay. Mike was wondering the difference, have you looked at all difference between the dipole and inverted V, if the apex of the inverted V is at the same height as the dipole? Do you have any comments on that?
Yes, I have done this study because of the 160 meter system I have, so I didn't cover 160. So my 160 meter system is an inverted V in practice with apex at about 120 feet. So that is what I have at both locations, OH0V and OH4A. And the more straight your antenna is, the better it is. But if your apex is something like wider than 90 degrees, then you are mostly horizontal. It's better gain-wise, but you are also going to have some vertical part, which is going to be helping you a little bit with your radiation pattern towards the horizon. So it's going to be helping you marginally to the DX, but the higher you can get the apex and the more straight the dipole can be or the inverted V can be, the better. But there's no let's say strict figures what you must have, what you should be avoiding, but the higher you can get your feed point, the better.
Okay, Jukka, I just want to check your email address is okay on qrz.com.
jpklemola@gmail.com.
Okay, but on QRZ.com, do you have your address listed there also?
Yeah, it should be correct there. Yeah.
Okay, if anyone wants to look you up. Two questions here. Let me go ahead, since we're talking, or we were talking feed lines. Do you have any experience using open wire feed line, especially for long runs where, you know, you talked about the expense of hard line? Any experience with open wire feed?
Not myself. I visited Glenn K6NA a couple of years back. He has his 80-meter system done with open feed line, and I loved his solution. What he has or he had back then on 80. I think Glenn has that back because he has been on 80. So, and he is pretty strong there, by the way. So it's high impedance. It means there's less current, which means there's less loss if for a certain diameter of the wire or amount of copper. So if you have time and stamina to build your open feed line, by all means do it, and then you need to be able to match it to 50 ohms or whatever your transmitter output impedance is, and you need to be understanding also the antenna impedance, and if you can design the system, the open wire feed line, it's a great choice.
Okay, I know they use that in a lot of broadcast and shortwave stations, especially on long runs.
Yeah, the only caution with the open wire feed line is safety. So there are going to be high voltage points, or the whole system is about high RF voltage. So you need to be able to keep not only people but also animals out of it. And if you succeed somehow in that, then you are really okay. I think birds will fly out if you are showing any kind of RF energy. They will just leave your system.
I could start my trees on fire, huh?
Yeah, potentially yes. But there's also this possibility. But with thoughtful implementation, it's a great thing to have.
Correct. Yes. Okay. Any thoughts on receive antennas for like the low bands? Have you done much of that?
Thank you for pinpointing the other thing that I did not touch in the presentation. So at OH4A, I have 2 acres or about half a hectare. I have there 2 towers which are 45 meters tall. So that kind of covers my whole property area at OH4A. But I was struggling on 160 meters because I have invested into an amplifier that outputs 1.5. So I was getting this kind of sensation that there are stations calling me that I cannot hear. So I had to invent something for the low bands receiving. So from this ON4UN top band DXing, I found these EWEs. I tried those antennas, but I wasn't exactly happy with those. The ground things or the ground effects were not well done or at my end, so I couldn't get them functioning to my satisfaction. Then I was thinking about K9AY. I decided that, well, it also has ground connection. So then there are these flag or pennant antennas, and I found those to be my solution. So a closest reference to what I have for 160 meters and also 80 meter receiving, by the way. So I have a 2-element Yagi on 80, but I'm benefiting from this kind of it's a Fox Oscar 0 alpha 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 antenna. So if you go to Google and you just put your Fox Oscar 0 alpha 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 receiving antenna, I think it will guide you to construction details at the necessary level, so you can duplicate what I have done. And I have an array of 6 of those antennas on my property, and I can switch them. And typically I can hear stations, maybe 20, maybe 30 stations on 160 meters that I wouldn't be able to operate with my wire antennas or transmit antennas. So this receiving system increases my 160 meter score by 10%, and I'm very happy with that.
Okay, very good. This next question, I don't know if you're going to have an answer for this, and if anyone else has comments, go ahead and send them in, and I'll pass them along as well. But they're wondering, do you have a recommendation for a commercial vertical for the lowest radiation angle?
On what band?
I'm going to guess probably like 80 or 160, the lower bands.
Well, my favorite on 80 would be I have had at OH6LI full size quarter wave vertical, and I was pretty pleased with that until I had an opportunity to have just about horizontal antenna up more than 30 meters. So that was a winner against this ground plane on 80. So, but commercial manufacturer, I think there's a couple of European manufacturers. I'm sure that there are companies manufacturing those also in US. But then, if you think about these multi-band ground planes, the radiation pattern is not really so much dependent on the ground plane, but the height of the ground plane. So the higher you can place your antennas, so that it's away from the obstacles like your house primarily. Then also if you can go above the trees with your antenna, it's going to be showing some additional gain. But the house is typically a attenuator or reflector or whatever. So. Or neighboring houses. So if you can go above those, it's better.
Okay, yeah, I know there are more and more of them showing up here commercially made in the U.S. I unfortunately don't have a lot of experience with them. A lot of them are, especially for 80 or 160, are physically short, and they're loaded electrically through various means. But okay, another question from Thomas, Papa Yankee to Zulu X-Ray United. Jukka, I remember you previously had stacks on 2 towers for the same band, kind of like a virtual 4H, I guess the horizontal configuration. If you've made it any experience or modeling, how far off can you turn the beams off the square direction? You want to speak to that arrangement?
Yeah, General. Yeah, he's originally a Swedish guy residing now in Brazil. I think we have met a couple of times. Hello there. Thanks for joining. So, and thanks for asking. Actually, this array of 6 Yagis on 20 meters, I still have it at OH4A, but I have been adding all bands to both towers. So I have all 6 bands on both towers at OH4A. So I have experimented that it matches the expectation broadside towards USA, both short and long path. So I'm getting the additional gain, and I'm getting the additional attenuation to Europe, the signals that are close by. And then when I'm using those into different directions, like the other one is to JA and the other one is to Europe or USA, the radiation patterns don't really mix up, so I don't get any unwanted nulls. I haven't been able to find any of this kind of unwanted things in the radiation pattern. And originally I had this 6 times 4 element Yagi on 20. I had it so that I was using all 6 Yagis all the time, but now I have a relay, or I have a matching unit, so that I can select which tower I'm using. So I decided not to have any relays on towers, so that I could be selecting which Yagi or which pair I would be using. So I'm using 3 Yagis on both towers, and I'm happy with that arrangement, with the add-on of this low quad that I have there today. So I feel that I'm doing pretty well on 20.
Okay, very good. Let's make this the last question then. This comes from Ari, and he's asking to maximize the number of Yagis on one tower. What's the minimum stacking distance between Yagis of different bands?
Okay. If you are mixing Yagis, the only pair of Yagis I have been concerned width is 40 and 15 meters. So I have been keeping those separated by more than a quarter wavelength on 15. So I have been keeping them at least 5 meters from each other. So that's my only rule of thumb. Anything else goes, so that at OH4A, my upper 40-meter Yagi and highest 20-meter Yagi, they are separated by about maybe 4 feet or a little bit more than a meter. So they are doing just fine. So there's no change in the SWR pattern. And the number of Yagis on a tower, I have 10 Yagis on both of my towers at OH4A. So I have 10 Yagis, and those towers are 45 meter tall, and the lowest Yagis are at 20 meter level. So I have 10 Yagis along a 25 meter run of tower.
Okay, very good. Well, that does it. Thank you very much, Jukka, for your presentation. Great information. As I was telling Jukka beforehand, very happy to have participation and presentations from our friends over in Europe. And if there are others in other parts of the world that want to do this as well, certainly love to have you. So before I close it down, Jukka, is there anything else you want to add?
I'm open for email discussions, so in case there are any questions or requests for the presentation, request or of more information, I'm happy to share.
Okay, that's great. Yes, and as a reminder, it's OH6 Lima India. You can look him up on qrz.com. Send me an email if you need to, and the presentation's been recorded, so that'll be on the WWROF webpage, hopefully in a couple of days, and you'll be able to see the entire presentation there again. So Jukka, thank you very much for your time pulling this together, sharing the information with us, and thanks to everyone who joined us today, and we look for you on an upcoming presentation. I had a couple of things I was close to getting scheduled, and then we had to postpone for a variety of reasons, so we've got some other good topics coming up. Just stay tuned. I'll send out an announcement as soon as we can get dates nailed down. There we go. All right, thanks everyone. Have a great day. Jukka, thank you once again. 73s everyone. So long. Bye-bye.